Okay, boys and girls, today we are going to be reviewing dividing unit fractions by whole numbers. And it's very similar to what we did yesterday. We're going to be building on what we did yesterday. The only difference is that today we're going to be putting the fraction first and then the whole number. So the steps are going to be exactly the same. So our notes today are going to be more practice rather than writing steps down. So let's go ahead and start by titling our notes. Dividing unit fractions by whole numbers. Okay, so for my notes for today, what I'm going to be doing is I'm going to be asking you to create a triple T-chart. So I'm going to be doing it like that, and then I'm going to be splitting it up right here again. Because we're going to be working with the three strategies that we learned yesterday to solve the same problems. So we're going to be using standard algorithm here. And we're going to be using pictorial models here. And then on this section, we're going to be doing the number line models. Okay, so we're going to get started with the standard algorithm first. And one thing that is very important to remember is that the strategy that we use for standard algorithm for dividing fractions is keep, change, flip. We're going to keep the first fraction. Division is going to become the inverse. Division changes to multiplication. And we do the reciprocal of the second fraction. We flip it. The denominator becomes the numerator, and the numerator becomes the denominator. So let me go ahead and give you a sample problem. Let's do 1/4 divided by 3. Now to solve this problem, the very first thing we need to do is we need to convert that whole number into a fraction, and we do so very easy. You just put a 1 underneath. Now we're working with two fractions. Now we can go ahead and implement our keep, change, flip steps. Keep, change, flip. The first fraction is going to stay the same, 1/4. Division is going to change to multiplication, and we're going to flip the second fraction. The 1 is going to go up, the 3 is going to come down. Now all I have to do is apply my multiplication steps. 1 times 1 is 1. 4 times 3 is 12. You don't need to simplify. You don't need to convert. This is your final answer. My answer is 1/12. Let's go ahead and do another example. Let's do 1/3 divided by 2. Again, we are doing the fraction first this time because today we're dividing unit fractions by whole numbers. So the fraction needs to be first. And then we're dividing it by a whole number. So the whole number is second. But nonetheless, the steps are the same. I need to convert this whole number into a fraction by putting a 1 underneath. And then I'm going to apply my keep, change, flip strategy. The 1/3 stays the same. Division changes to multiplication, and I'm going to flip my second fraction. The 1 that is the denominator is going to become the numerator, and the 2 that is the numerator becomes the denominator. The 1 comes up, the 2 goes down. We flip them upside down. Now all I have to do is apply my multiplication steps. 1 times 1 is 1, and 2 times 3, or 3 times 2, is 6. The answer is 1/6. Let's go ahead and do another example. And again, you may find this very easy because it's pretty much reviewing what we learned yesterday. The only thing we're doing different is we're switching the numbers. Yesterday we had the whole number first. Today we have the fraction first, but the steps are exactly the same. Let me go ahead and give you one more example of how to use standard algorithm to solve this problem. Let's do 1/4. Oh, we already used 1/4. Let's do 1/2. 1/2 divided by let's see, 1/2 divided by 4. That's a good number to use. Okay, 1/2 divided by 4. First thing to do, change that whole number into a fraction. And now all we have to do is apply our keep, change, flip strategy. We're going to keep the first fraction. 1/2 stays the same. Division changes to multiplication. And then we're going to flip the second fraction. The 1 is going to come up. The 4 is going to come down. Now all I have to do is apply my multiplication steps. Numerator times numerator, denominator times denominator, making my final answer 1/8. The 3 problems we solved here use numbers, use operations. Therefore, when you use numbers and operations to solve, that's considered standard algorithm. And that's just a fancy word for just regular math, what we're used to doing all the time. So now let's go ahead and do the pictorial model, which is a different form of solving dividing fraction problems. So for the sake of proving that it doesn't matter whether you use standard algorithm, pictorial models, or number line models, it doesn't matter which one you use, you'll get the exact same answer. We're going to be using the exact same problems. That way we kind of already know the answer, so it's going to help us prove that what we're doing is right. We have 1/4 divided by 3. 1/4 divided by 3. To solve this problem, you need to think of the fraction in a different way that we don't normally think about it. We are going to look at the first number, and like yesterday, we are going to think about it as what we have. And what I have is 1/4. So let's just say that I baked a cake. Here's my cake pan where I baked my cake. My family ate 3/4 of it, so 3/4 is gone. The only thing that I have left is 1/4. So let me go ahead and show 1/4 here. And I'm going to shade in 1 because that's what I have. I only have one little piece out of the cake. Everything else they ate. I have 1/4. The fraction, the first number, is exactly what we have. We are going to split division means to split, to cut up, to put into equal pieces. We're going to split this little piece into 3 because I have 1/4 of my cake and 3 of my friends are coming over and they want a piece of it, and each one wants to get the exact same piece. So I'm going to take this and I'm going to cut it into 3 equal pieces. And then I'm just going to take this line, only to make everything exactly the same. I'm just going to run them all the way through. Run them all the way through. And what I want to know to figure out my answer is the value of 1 part. How much is one little piece that my friend is eating? How much is that one little piece worth? And it's worth 1 piece out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 piece out of 12. 1/12. 1/12. 2 different ways of looking at the problem, but you get the same answer. Let's go ahead and do the next one. Let's continue to develop that using the picture to solve the problem. We have 1/3 divided by 2. And again, the first number is always what I have. I have 1/3. I made a lasagna. Here's my pan. My family ate 1/3, they ate 2/3 of it. And the only thing that I have left is this 1/3. That's the only thing that's left over. Everything else they ate. And then my 2 brothers came over and they each wanted a piece. So we need to cut that piece into equal parts of 2. So that each one of my brothers gets the exact same piece and they don't feel like they got less. So what I'm going to do is I'm going to cut this in half right there. And then just to make everything equal, I'm just going to extend this line all the way through like that so that all pieces are equal. And then to figure out my answer, all I have to do is figure out how much one little piece that one of my brothers ate is worth. I want to know the value of 1. The value of 1 piece. So it's 1 piece out of 1, 2, 3, 4, 5, 6. 1 6. 1 6. 2 methods, same answer. Let's go ahead and do the last pictorial model here. We have 1/2 divided by 4. This time I made brownies. And my family ate half of it. And the only thing that I have left is half. The other half that they did not eat, which is this one right here. They did not eat that part, so I still have that. 4 of my friends came over and they each wanted a piece of the brownie. So what I have to do is I need to take this piece here and cut it up into 4 equal pieces. So I'm going to cut this half in half, like that. And then I'm going to cut this half in half. And then this one in half. And I'm just going to extend my lines all the way through. And my answer here is 1 of those pieces. 1 piece out of 1, 2, 3, 4, 5, 6, 7, 8. 1/8. 1/8. 2 methods, same answer. Let's go ahead and move on to the number line model, which is the third method that we need to know to be able to solve these problems. So again, I'm going to use the exact same problem. That way you can see that it doesn't matter which one you use, the answer is always going to be the same. We have 1/4 here divided by 3. So this is a number line model. So the first thing I'm going to do here is I'm going to draw my number line. And I am going to consider what I have. And I only have 1/4. Let me make sure that you can really see what I'm doing. Yes. Okay. I have 1/4. So I'm going to start here at 0 because all number lines start at 0. And I'm going to end at 1. I don't need that many numbers because in reality, all I need is 4th. So I'm going to take this whole, cut it into 4 equal pieces. That's my denominator. And of those 4 pieces, I only need 1, which is my numerator. I'm drawing the 1/4. So I'm going to take my highlighter and I'm going to highlight from the 0 to the first little tick mark. This is what I have. I have 1/4, 1/4, 1/4. I'm going to cut that 1/4 into 3 equal pieces. 2 little lines, make 3 spaces. Now from there, what I do to 1, I have to do to all. So I'm going to cut this into 3, cut this into 3, and this one into 3. Just putting 2 little lines in each makes 3 spaces. And to figure out my answer, I need the value of one of those little pieces. So I'm going to take one little hop here from 0 to the first little tick mark. And that is worth 1 little hop out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One little hop out of 12 to get from the 1 to the 0, to the 0 to the 1. 1/12. 1/12. 1/12. 3 different strategies, same answer. So it doesn't matter which one you use, all 3 of them will get you the same right answer. Let's go ahead and do another one. Let's do the next one. 1/3 divided by 2. 1/3 divided by 2. So I'm going to go ahead and start by creating my number line. Start at 0, end at 1, and of this little piece, I only want 1/3 of it. So I'm going to cut it into 3 equal pieces, and of those 3, I only care about one of it. From the 0 to the first tick mark. That is what I have. I have 1/3. 1 out of 3. 1/3. I am going to cut that one little piece into 2 pieces. So I'm going to put a little line there. 1, 2 pieces. And what I do to one, I have to do to the other. Because math is fair. What you do to one, you always do to the other. So what I want to know is how much one of those little hops is worth. The value of one of the little hops. So it's going to be 1 little hop out of 1, 2, 3, 4, 5, 6. 1, 6. 1, 6. 1, 6. 1, 6. 3 different methods, 1 right answer for all 3. Let's go ahead and do the last one here. Let's do 1/2 divided by 4. And again, we're going to start by creating our little number line. Start at 0, end at the number 1. And of this 1, I only need half of it. So I'm going to cut it in half. And then with my highlighter, I'm going to shade in from 1 to the first tick mark because I only need half of it. That's all I need. And I'm going to cut this half into 4 pieces. 3 little lines make 4 spaces, and then what I do to one, I have to do to the other one. 3 little lines make 4 spaces. And then, as I've already said several times, to find the answer, all I need is the value of one of the little hops. From there to there, I have 1 little hop out of 1, 2, 3, 4, 5, 6, 7, 8. 1/8. 1/8. 1/8. 3 methods, 1 right answer.